Line. So I am from Polytechnic Sultan SALAHUDDIN ABDUL SHAH. So today I would like to present my technical paper. So my technical paper title is Development of Media Monitoring based on ROTARY Potentiometer and Application. Here is my table of content, which is consists of 5 parts, which is introduction, related words, methodology, design, and conclusion. Let's move to the introduction. So, physical activity usually does not cause problem, but surprisingly, daily wear and tear, overuse, or injury can cause symptoms. So, knee injury are regular due to falling and illness, for example, ligament problem. While doing the rehabilitation, the physiotherapist did not know how much the patient can flex their injured knee. So, a body-mounted knee joint angle measurement chart was built using a potentiometer as a flexion sensor. So, an application for real-time monitoring and exporting knee joint angle measurement to a smartphone. So, knee health system may examine a patient's range of joint motion of knee. Let's move to the related work. So, related work for number 1 is knee joint, which is the knee joint is a hinged synovial joint that mainly allows flexion and extension. So the patella, femur, and tibia articulate to form this joint. So the 4 ligaments which are thick tissue bands that anchor the joint to keep the joint stable. So number 2 is the medial and lateral collateral ligaments MCL and LCL, as well as the anterior cruciate ligament ACL and posterior cruciate ligament PCL. So on the upper surface of the tibia, there are 2 sharp absorbing cartilage called meniscus. So the meniscus is inside the knee. The meniscus is enable the femoral condyle to glide across the tibia surface without pressing against it, prevent the bones from rubbing around each other. Related work number 2 that I have researched is about sensors. So number 1 is the potentiometer, which is the dial of potentiometer is counterbalanced with a weight to allow for iterative adjustment to the effective axis of motion. So the potentiometer set up for measuring flexion and extension angles. Number 2 is the flex sensor, which is a human body mounted knee joint angle measurement solution using a flex sensor as a flex or sensing resistor. So this project proposes a portable, lightweight knee joint angle measurement system that can be easily to put on and taken off through a wearable sensor. For related work number 3 that I've been shared is about the connection, which is the Bluetooth module. So this application uses a Bluetooth-based algorithm to accept knee joint angle and acceleration data from a wearable frame attached to the knee joint and discern between lower extremity movement. So a real-time posture identification and monitoring application was created to identify and display a user's static, which is standing, lying, sitting, and dynamic walking velocity posture in a text bar in a real time. So number 2 is about Node MCU ESP8266, which is an open access wireless data gathering system that monitor and record a limited number of characters. So this problem can be solved by implementing the proposed Internet of Things, which is IoT data collection system. So the data collection method present is based on open source software and a cloud service. So the proposed data collection system is adequate, dependable, cost-effective, and suited for hard-door situation for monitoring and obtain operational information. To the methodology, this block diagram shows how the device is functioning. So as a power supply, I use battery lithium 3.7 volt. So the potentiometer sensor will detect the movement of the knee for estimate the angle of knee bending and transmit to Node MCU ESP8266 to process the data to display on mobile phone. So the application of the saving data is Blink. So the software implementation that I have been used is Arduino IDE and Blink application. So this project uses Arduino IDE for software to program the coding. So the Blink is a hardware-independent IoT platform with mobile application, with white label, private cloud, device management, data analysis, and machine learning. It is an IoT platform that connects your device to the cloud. It's designed to control their application, analyze telemetry data, and manage deployed product at scale. This application uses a monitoring device. Here is the product overview for my technical paper, which is content of hardware and mobile application. So this project can be used at home for patients who had knee injury or problem. Hence, it will be easier and more comfortable for patients to do their exercise at home and know their own progress while be monitored by the therapist from far by using the cloud. So the Blink app that is easy to download on either Android or iOS make it an easy community to use even more widely. So to determine the consistency and reproducibility of the knee joint ankle data for the proposed monitoring system, a test was conducted. Result. So table 1 show the different angle and different posture in average of 10 minute exercise. Hence the graph in the data is taken in each mean value of every minute. Figure 1 is to show changes in the angle of the knee joint between 0 degree and 10 degree could not be distinguished, but for angle greater than 10 degree, the angle measurement could be accurately reproduced. As the knee joint angle adapt in daily life, for the most part is between 0 to 60 degree during walking, 0 degree until 90 degree during sitting or standing. So the majority of lower extremity movement are performed with a knee joint angle over 10 degree. So this indicates that the proposed knee joint health monitoring system is suitable for use in classifying lower extremity movement. The result is about the value of P out was measured versus the rotation angle for each output respectively, and the average of the reading was recorded in table 2. The key characteristic of most potentiometer design is its linearity, which is usually defined as the proportional difference between the actual output voltage and calculated voltage. Potentiometer position at hinge of the top and lower leg of the wearable frame are used to measure knee joint angle. Hence, the monitoring system consists of wearable frame that is one on the knee joint and contains a sensor for monitoring the knee joint angle as well as a wireless communication device for transmit biosignal to a smart device. Thank you from me, that's all.